To start the discussion of circular motion, I want to introduce a new unit for measuring angles. So far we have used degrees, but it is clear that 360 degrees in a circle is no more than an arbitrary choice. We wish to find a measure that has more physical meaning. Finding a replacement is not too difficult. Pi arises as the ratio between a circle's circumference and its radius, and we know that the circumference is equal to 2 pi r. We also know that the length of any arc of a segment of a circle is equal to the ratio between the angle of that segment, theta, and the total angle of the circle, which we previously called 360 degrees, multiplied by the circumference 2 pi r. What if instead of 360 degrees, we instead called this total angle of the circle 2 pi? This would do the job of cancelling the 2 pi's in this equation and leaving us with the nice expression that the arc length is equal to the angle of the segment theta times the radius of the circle r. The new angle unit is a radian, defined so that there are 2 pi of them in a whole circle. The angle of a straight line is therefore pi radians, and a 90-degree right angle is now pi by 2 radians. To switch from degrees to radians, you simply divide the angle in degrees by 360 and multiply it by 2 pi. The area of a segment of a circle with angle theta is equal to the ratio of theta to the total angle times pi r squared. If we use radians, the total angle is 2 pi, and so this simplifies to the area is equal to angle over 2 times r squared. These formulae are useful in solving physics problems. Let's look at circular motion and say that an object is moving around in a circle periodically at a constant speed, like an ideal satellite in orbit, and we know the time period of the orbit is t. The speed of the object must equal the total distance it travels around during one orbit over the time it takes for one orbit, or 2 pi r over t. This term, 2 pi over t, we define as the angular speed. Since 2 pi is the total angle in the whole circle, the angular speed tells us what angle is being travelled around per unit time, usually seconds. Just like the translational speed tells us the distance that is being travelled per unit time. Since the time period of the orbit is equal to 1 over the frequency of the orbit, we can also write the angular speed as 2 pi times frequency. Multiplying the angular speed of the object by the radius of the orbit gives us the translational speed of the object. This allows us to rewrite the equation for the translational speed of the object as v is equal to radius r times angular speed omega.